Hi guys, welcome to this lesson. So in this lesson, we want to look at intersecting lines. So intersecting lines is just like simultaneous equation. We also have this lesson under coordinate geometry where we treated intersecting lines. So when two lines intersect, they have a solution, and the solution is the point of intersection. So when two lines are parallel, the lines are said to have infinitely many solutions. And when two lines are coincident, okay, so there is no solution. So two lines intersect if they have one point in common, and two lines are parallels if they travel in the same direction and never meet. Two lines are coincident if they lie on each other, okay, infinitely. So these are intersecting. So our purpose here is to learn intersecting lines. How can you use vector to represent intersecting lines? So apart from intersecting lines, we also have what we call skew lines. So skew lines are lines that are not parallel. So skew lines is different from parallelity and perpendicularity or intersection. Okay, so they are just some special lines. They are not parallel and they do not intersect and are not coincident. So those kind of lines are called skew lines. Skew lines are not parallel, they do not intersect, and they do not lie on each other. Okay, so like we can see here, if you look at the diagonal, look at this diagonal here, and then look at the other diagonal here. Do you see that these two diagonal AC and DG do not, we cannot say they are parallel, but they do not actually intersect, because if we extend this one, okay, so they may actually be parallel based on some principle, but they do not actually intersect anyway. They do not intersect. So here, AC and GD are skew lines. Okay, they are skew, no intersection, and they are not parallel, and they are not coincident. Okay, so those are the kind of line that is called skew. So, and of course, they have different direction and no point in common. They do not have any point in common. They are not on the same plane. They do not fall on the same axis, and so on and so forth. Okay, so here let's look at some problems involving this kind of situations, and let's see how we can just solve them. So, uh, basically, let's look at some of these questions first. Example one. Example one. The lines uh, L1 and L2 are given by the vectors. So consider the lines. Consider L1 and L2 as follows. So the first one, R equals to 5, 1 minus 1 plus T bracket 2, 1, 5. That is L1, and this is L2. R equals to 13 minus 6, 2 plus mu into minus 3, 4, 1. Okay, this is respectively. Show that the lines intersect and find the position vector of the point of intersection. Show that this line intersects and then find the position vector of the point of intersection. So we have to do two things. A, show that the lines intersect, and B, find the position vector of the point of intersection. Alright, so uh, you can see that either the lines must intersect or else they are skew, okay? Because I don't think they are parallel. If they are parallel, they will have the same representation. They will have the same coefficient of t, okay? They will have the same vector coefficient of t. So their direction is given by, we have the direction, we have B1. The directions are, So we are solving A. So the direction of this vector are b1 equals to 2, 1, 5, and b2 equals to minus 3, 4, 1. So these are the directions of the vector that we have. And then we have the point. We have the point a1 equal to 5, 1 minus 1, and a2 equal to 13 minus 6, 5. So these are the points we have. So for the lines to intersect, they must have the same value of t and a value of mu, which give the same position vector from each equation. So they must have the same value of t and the same value of mu. So what we are going to do is, let's call this R1 and let's call this R2, so for simplicity. So solving for A, for the line to intersect, L1 must be equal to L2, which implies that R1 must be equal to R2, which implies that the vector 5, 1 minus 1 plus t of 2, 1, 5 must be equal to 13 minus 6, 2 plus mu of minus 3, 4, 1. Okay, so if this happens, then we have 5 plus 2t, okay, 1 plus t, and minus 1 plus 5t must be equal to 13 minus 3 mu, and minus 6 plus 4 mu, okay, and 2 plus mu. So if we can show that these equations are equal, then the line actually do intersect. So equation, we have how many equations are we going to form if we solve this equation? We're going to have from the first one, we're going to have that 5 plus 2t equal to 13 minus 3 mu, okay, yep, and that 1 plus t equal to minus 6 plus 4 mu, and that minus 1 plus 5t equals to 2 plus mu. Okay, so let's call this equation 1, equation 2, equation 3. Okay, and what do we have here? So we can just eliminate mu, and we'll try to solve some of these parameters. So we can multiply this equation by 2 so we can eliminate t. So this is what we have. So let's say 1 minus 2 times equation 2. Okay, and that will give us 5 minus 2, which is 3. 2t minus 2t will be 0. Minus times minus is plus. 2 times 6 is 12. 13 plus 12, that will be 25. Okay, this is minus times plus is minus. 2 times 4 is 8. Minus 3 plus 8. Minus 3 plus 8, that will be plus 5. Sorry, is that minus? Minus times minus is minus. Minus times minus. Okay, let me do it very well so that you see what is happening here. So this is 5 plus 2t equals to 13 minus 3 mu, and minus 2 minus 2t equals to 12 minus 8 mu. Okay, and then by the time we add it together, we have 3 equals to this is 25 minus 11 mu. Okay, so solving this equation, we're going to have the value of mu. So we have 25 minus 11 mu equals to 3. So minus 11 mu equals to 3 minus 25. So minus 11 mu equals to minus 22. Dividing both sides by minus 11. So this is going to cancel. Mu equals to 2. Okay. Mu equals to 2. So that is what we have. And then we can use any of the equation to find t. So let's use the first equation to find t. So we have that 5 plus 2t equal to 13 minus 3 mu. 13 minus 3 mu. So 5 plus 2t equal to 13 minus 3 times 2. So which is 13 minus 6, which is 7. So 5 plus 2t equals to 7. 2t equals to 7 minus 5. 2t equals to 2 divided by 2. T equals to 1. Okay. So alright, so these pairs of value also satisfy the third equation, and we have shown that the lines intersect. So you can see that we found the value of t and that. So if we substitute back in the equation, so substitute t equals to 1 in R1 and mu equals to 2 in R2, we're going to have that R1 equal to 5 1 minus 1 plus 1 into 2 1 5. Okay, and that would be equals to 5 plus 2 or 1 plus 1 minus 1 plus 5. Okay, which is equal to 7 2 4. Okay, and then R2 will be equal to the parameters as well. 13 minus 6 2. Okay, plus 2 into minus 3 4 1, and that will be 13 minus 2 2 plus, so if we do this we have minus 6 8 2. Okay, so which is 13 minus 6 is 7, or minus 6 plus 8 is 4, and what do we have there? So something is fishy there, so we have 2 times 2, so this is 4. Yeah, it's correct, it's correct. So 2 plus 2 is 4, so we still have minus 6. Minus 6 plus 8 is 2, right? So we still have 7 2 4, so it's the same thing. 7 2 4. Okay, so that's 7 2 4, and you can see that R1 equals to R2, so which implies that L1 and L2 intersect. So this is how you find intersection of the lines. Okay, so we have the second question there of find the position vector of the point of intersection. So the position vector of the point of intersection is what we have found. So find the position vector of the point of intersection by substitution, by substituting the value of t into the equation. Okay, so therefore we've answered the question B. So the position vector is 7 2 4 that we have found. Okay, that's good. Position vector is equal to 7 2 4. Okay, which is what we found when we substituted the two values into the equation. Okay, so this is how you work with lines. Okay, so the